Um, is this big enough for you guys? Just to make sure. Okay. Okay, I guess welcome back to day two. So today we're gonna look much deeper into the package called dplyr. We're gonna learn how to do data wrangling, how to change the data shapes of the data, um, data frame to be specific, and we also gonna learn how to visualize our data frame with ggplot2 package. And after that, we're gonna do some basic statistical analysis like t-test at the end. So before we begin, we need to load all the necessary packages that we installed yesterday. So you gotta, same as yesterday, you just need to load it. Again, you can load the package using this method, but much straightforward method would be library and the package name IDER. And if you have multiple packages, you can use the multiple lines to load it like this. And then we also need to load our data set from yesterday. If you remember, you're supposed to be in part 1 directory. Make sure you set that as a working directory. And we should load 2 data set for today. We should load this one, CBPH vaccination county totals. And so just to recap, read.csv, since this is a CSV file, we know that the file has a header from yesterday, right? This part is not necessary since the default separator is already a comma for read.csv function, so we can delete it and we can run it. Wait, let me just clear out my environment real quick. And you can see that the county vax data again with 25, nearly 26,000 rows and the 21 columns, right? And then, yeah, you can also check the data by clicking the variable at the environment panel here. You can see the data in a table format in a separate tab. And you can also use something called hat function to just see the to see the top 6 rows of the data. And likewise, you can also use the tail function. This function basically shows the data from the bottom 6, I believe. Yeah. And again, you can also load there are 2 different methods, right? So you can also use the read.table. For read.table, the default separator, I believe, is a tab, which is this symbol here. So you gotta make sure that you put the separator as a comma when you are using a table with CSV file. We did learn some of the dplyr function yesterday, which is a select and filter. So as we know, we can pass on the data frame. Here we're passing on the county pop data frame, And then the rest is the column name, right? So we are selecting the column name of this data frame. So if you take a look at the county pop, there's a 4 different columns. There's a rank, county, population, and then the population, the per 10K, which is basically population divided by 10,000. So it's much easier to read, I guess. But I guess we don't need the rank column here, so we're just gonna remove it by selecting only the 3 columns here. So county, population, and per 10K, and we're gonna store that into a county pop filter. So if we do that, you see we still have the same number of rows as county pop, but again, we just removed the column rank so that we now have the 3 columns. Okay, so that was a bit of a recap, right? So now we're gonna learn how to do the joining of the table. So joining of the data frame requires specific column, specific anchor point, which means that the column, whatever stuff in the column has to be matched with the other columns in the other data frame. So here we see we have county data here, right? And if you look at the county vex data, you see that there is also a county column here. So we know that we can use this county as an anchor point for 2 different data tables, and we can merge it together. Here we're using the function called left join. There are different joining method available. I think it will be easier if we see the illustration here. Maybe there might be a better one. Yeah, this one's better. So the method we are using here is a left join, right? So we are adding county pop filter that we just filter from here with the county vex data, right? So here we are doing left join, which means everything in county pop filter will be added, as well as some of the stuff that are intersected with county vex data will be added here. So some of the data will be loose if there is no intersection within the right table, which is a county vex data, right? So if you want to make like a union of 2 different tables, you want to use the full join function. Similarly, you can also do the right join, and just I think this one in R is an inner join, which basically calculates the only the intersection of the 2 different data frames. So, like I said, we'll be adding 2 different data frames, and then we are also telling the function that we are using the column county as our anchor point. If you note that there is the difference here. Here the county is county starts with a capital T, I mean capital C, where here the county starts with a smaller letter. So if you notice that in the county vex data, we actually have the column name county with a small c, where county pop it has a county column with a capital C. So you gotta make sure that column names are correct when you're going to different tables. So if you run that, let's see what happened. Obviously, the rows are the same rows are the same as this one, county vex data. And then we note that we also added 2 additional columns from county pop filter, right? You see, so this 3 columns is from county pop filter, right? County population per 10K. And the rest is from the county vex data.ca. The rest of the columns are. If you note that the county information from county vex data is now merged into the county, the first column here. And yeah, so I just described how the inner join, left join, right join, full join works. We can also, yeah, we can actually try different joining method. Yeah, I think even if we do the right join or inner join, we should be we should get a like same result because all the county information is there, right? So it's basically all the county informations are intersecting to each other from 2 different tables. Yeah, so and then we can also talk about a little bit advanced way of using dplyr package. So again, the filter, I mean the select method we used, if you recall, we passed the data frame at the very first parameter of this function, right? And then if you want to write multiple dplyr functions using this method, you gotta repeatedly like pass on the data frame, right? So let's say if you want to filter, so here we selected 3 different columns here, and then let's say we want to filter out let's say we want to filter out the county, the Los Angeles only. Right. And if you check this out, you see that there's only 1 rows, right? But if you like do like multiple restriction or filterings like this, you are like you're repeatedly writing the data frame into the function, right? So if you use the pipe here, you can actually ignore the path passing on the data frame on the first parameter here. So if you're setting the multiple filters here, you can use pipe like this. Oops, sorry. And then, so at the very left hand side here, it should be the data frame that you want to pass on. So you're basically creating a pipeline, right? So you're telling the R, okay, I have this data frame, pass it on to the function that comes after this pipe. And so you don't have to write the data frame at the front here. Instead, you just need to you can just write the column name. And then after that, you get some results having these 3 different columns, right? And then you're passing that data frame again to filter. Again, you don't need this additional data frame here, and then we are filtering out the Los Angeles here, and then if everything's done, it's gonna pass the entire results back to the county pop filter here, which is why this arrow sign is here. If we do this, yeah, as you can see, same thing happened, right? So this is really a convenient way of writing a code. If you get familiar with the pipes, you can save a lot of lines of code just by using this simple symbol here. There are also some other method in dplyr. So mutate basically is to create a new column. And so select so far was kind of, we used it as to remove certain columns, and we also use the filter to filter out the certain rows with certain values, right? And then if you want to add a new column, you got to use the function mutate. Okay, and then yeah, and we have the vex data merge data frame from the join query up here, right? So we can use that to actually create a new column called the vex density here, which is basically it's a normalized value. Basically, it's basically the vaccinated people divided by per 10K population. So if you look at the vex data merged, so this is before we run the mutate. If you notice it, just show you call names, vex data merged. You see that there is no column name called vex density here. But if we run this code, so we are sending data frame, and then pipe, we're sending it to mutate function and creating this new column, which is using the fully vaccinated column here and divided by per 10K, which is up here, right? And then after that, we're filtering out the vex density value that is greater than 10. All right, so, and then whatever the results comes after is gonna get stored in the normalized vex data. So if you check the column names of the normalized vex data, you see that vex density is now added at the very end. You can also check it in a table format. Yeah, if we go to all the way down, you see that vex density is now added. All right. So Tayo, did you load the package as we did here?
Yeah, so I have the package. I loaded all of that. I can try it again, but I don't know, there's some, like, it had me restart the program. I see it, like, when I see my packages, it says that it's there.
So if you look at the packages panel here and maybe search dplyr, make sure the dplyr is checked.
Tayo, I think you just need to delete the comma. So where you have county pop $ population comma, you just need to delete the comma and then try running it again. Because the error you're getting is the comma is throwing off the name.
Okay, can you say that again?
So when you're running the county pop $ population, you have a comma after that. And you just need to delete that comma and try running it again.
How about you guys in person? Is everything okay?
Wait, I can speed up something. I'll maybe to load the file from this thing. Those things.
Oh, okay.
Yeah.
I think it froze, right?
Why?
Oh, it's open project. Yeah, I think it's closed. You can close everything out and it'll be open. Yeah, maybe you could. Yeah. Well, that's.
Is that working at all? How's that looking?
I missed a step like right before the normalized data.
It's not working. I don't know. I'm super confused.
Okay, well, why don't you send me in a direct message exactly what you're running and the error message you're getting, and we can work on it together, okay? That's what I'm here for.
It still loads, but yeah, I get those things, but they still load.
Oh, it works.
Yeah, it works.
That's weird. Everything worked. And what was your question again?
I missed a step after getting the county pop filter before mutating the data.
Okay.
So I did that part, but I wasn't sure we did before because I had restarted my computer.
Okay. Okay. Yeah, basically I just talked about the pipe, right? So pipe is, so when we did the filtering up here, we had to pass the data frame at the very first parameter in the function, right? But if we do that for multiple filtering, it's just a waste of space, right? So that's why we're using this pipe to just save the lines of code, right? So to use this, you first need to write the data frame at the very front here, and then you're telling the R to pass on this data frame to the whatever the function that comes after. So you can skip data frame part here, so you can just write down whatever the column name you want to filter out, and same here, and whatever the result is also passed on to the next function here, which is filter, and then county. And we were just filtering out the Los Angeles, right? Yeah, so that's basically it.
Okay. Did I see anything with this? At least.
So this is basic syntax, so you don't have to run anything.
Yeah. Yeah. Thanks.
So to
Okay.
see.
Did you download? Oh, yeah, here. Yeah. And starting. Yeah, so everything was started from here. Right, so you're good.
Thank you.
And you'll know, okay. So we're just filtering it out. So whatever the volume that comes after this, we're just filtering it out. Yeah, that, anything stuff that's lower than. So select is used when you want to select specific columns. Right? The filter is used where you want to filter out certain rows. That they're right. Here, so column for select it's in select just specific columns here, and then filter is used if you want to yeah. All right, so we can continue, I guess. So when we are, here we basically do some mathematical calculations, right? We divided fully vaccinated by per 10K. Sometimes there might be NAs added to the value. So you've got to make sure that NAs is filtered out. For this case, we didn't get any NAs, but like it's a good practice to always filter out the NAs. So we can use maybe stuff like filter, extensity. So the exclamation mark here means not equal to NA. For some reason, it's all gone.
Oh my God.
Why is that? You okay, Tayo?
No, none of it. I don't know.
Maybe you can share your screen so I can check it out.
Okay, sure.
Were you able to see what R version you're on?
No, when I type it in, it starts running through all of the different packages, and it's like there's like a warning, R tools is required, and then like some websites, and then trying URLs, and then package tidy unpacked. I don't even know. This is just
I think
terrifying.
what might be the problem is the R version might be old, which is a problem we were having yesterday when we kept getting the R tools error. So
Are you using Windows, Tayo?
Yes, I am.
I guess, yeah, you need to install R tools in that case. What version of R do you have right now?
So that's what I was trying to find. I typed in the command r.version, and then like this ensued. So let's see. Okay.
You can actually type in the session info.
Session info.
Yeah,
Okay.
session info with I in capital, and then brackets, round brackets.
All right, let's try that.
If you do that, you will see your R version at the very top of the line. Yeah.
Session info. Oh, with a capital. It says updating loaded. You know what? Let me just share my screen. This is just great.
Yeah, or we just stop sharing real quick so you can share.
Um, Okay, can you see?
Yeah.
Okay, so I typed session info
Mm-hmm.
and then this popped up. So should I? This is like the third time this has popped up.
I mean, just cancel it for now.
Okay,
Cancel.
I'm being held hostage.
Cancel everything for now.
I keep I'm hitting cancel. Okay.
All right.
Um,
And then do session info again. Go to session info and type Control Enter to run in your R console. Yeah, and go to scroll up a little. Yeah. So you have R to 4.2.1, right?
mhm.
And then you just need to install, I think. Here, let me just paste it here. Okay, go to this webpage on the chat.
Okay. 4.2.
Yeah, download the 4.2 version. You can click on the R Tools 42 installer at the page that comes up after.
Yep. It's doing it. It's downloading. Okay. I won't hold the class hostage. I'll just wait for it to download.
Okay, so once you install that, you can try to reinstall all the packages. And after,
Oh, okay. So I have to reinstall all the packages again.
yeah, I think so. I think your problem has to do with because you didn't have R Tools, your packages might not have been installed properly.
Okay.
Okay, so for this, I think, sorry. Normalized data, we're at removing all the NAs, right? I think there is some method in R. Maybe it's better to use each NA function here. And then maybe just something like this should work. You gotta put the exclamation mark here because we are looking for something that's not NA, right? Yeah, so it's really good common practice to always add the ease NA filter here after you do any sort of like mathematical operations. Just in case you created any NAs in your values. So
I have a question about NA.
uh-huh.
So this is like a real example. So I have a data set where in these two particular columns, there's various values where it's NA. And if I look in like an Excel sheet and I highlight the column or I type in like the average function, it'll give me a particular mean for each column. But when I brought the table into R and I isolated those columns to kind of stack them together so I can do like a histogram of like both groups, the mean changes. So does R interpret NA as 0 or
I don't think it consider as a 0. Maybe the reason is that you might if you remove the NAs, you might have changed the total N number of your row. Maybe that's why you're getting the different means there, right?
Hmm.
So if you want to consider your NA into something else, you might want to change all the values into 0 so that R can count them as a N. You know what I mean?
Okay, yeah, I know what you mean. So I think what you suggested about it being a different N and what I'm looking at in Excel versus in R maybe what's changing the average then.
So
Okay.
you don't want to apply this filter method because it's going to delete that row and decrease your N size, right?
Yes.
In your case.
Okay, thanks for that.
Actually, that remind me of some of the question that has been asked from yesterday. So if you recall, sorry, before we move on, I guess I just need to go over this real quick. So if you guys remember, yesterday we were trying to convert this string of number into a numeric variable, right? And it didn't work out. It turned everything into an A because there was a comma in between the numbers. So in order to get around with that, we need to change all the commas into empty characters. So we can use the gsub function here. County pop, population. Oh, sorry. It's actually the first. So let's look at the help function to get more. So gsub is used, you first type in your patterns and whatever character you want to replace with, and then your vector, right? So gsub, we are currently looking to change comma to nothing, right? So basically two double quotation here, and then county pop population. We do that, you see all the commas are now gone. Now you can apply as numeric here. Yeah, so you look at all the numbers, all the quotation, double quotations are now gone. And now this is a numeric vector, right? Another question that was asked yesterday was, so when we were doing if else statement, yeah, so in real life example, for example, if we are dealing with the RNA-seq data table, sometimes we have to deal with the different gene names. Sometimes we need to filter out the gene names we are interested in. And if we want certain genes are exist in terms of the variants, so there are separated by different numbers here, and they share similar names up front. So if you want to use if else statement to filter that out, instead of equal sign, instead of equal sign that we used yesterday, we gotta use whether certain character is contained in this word, in this genes, right? So if we were to use the double equal sign here, we're gonna get like numerous if else statements. So if we want to filter out, let's say ApoE1 and ApoE2, else if I and again, this is a waste of space, and coding extra lines. Coding extra lines is a waste of space, right? So in order to avoid that, we can use the function called grapple. So basically, it's gonna detect whatever the pattern you put in here. And so if your word comes in as a I variable. It's gonna detect every word that has an ApoE in it for this example. So if we do that, we see that since ApoE1 and ApoE2 were in the vector, we see ApoE1 and ApoE2 is printed. The caret sign here means the word has to be start with this specific word. If it's not, it's probably gonna throw out this gene as well. So if we test it again, yeah. So make sure you write down the gene name. If you know the complete gene name, you want to use the caret in front. I think that the question was asked by Ethan, right?
Yeah, I got one more question. So what does the ignore dot case mean? Or do we have to care about that?
Yeah, so ignore that case is just, so if it's set to true, it's gonna ignore the cases. If it's false, it's gonna be case sensitive.
I see. All right, thank you.
What error? It's not one piece. Where are we? All right, so we are at the filtering. We have done the filtering of NH. And yeah, next thing, so we can even do more sophisticated analysis using dplyr like this. So group by means it's gonna group everything by designated column here. So we're passing this specific data frame, county data CA, passing this data frame, filtering out specific dates. The greater sign here means that whatever that happened after this time period. And then we're passing that filtering result to group by function, and it's gonna group the entire row with county. And then we're gonna summarize that result table with mean new doses, mean new Pfizer doses, Moderna. So this is a COVID vaccination record. So that's why we're seeing this different vaccines doses here. So if we do that, let's see what happens. Maybe it's better this way. Yeah, so we can see that county vex data actually had, like, for example, let's say this. Actually had multiple rows of Los Angeles data, right? Now everything is combined into one row, and then the mean value is added as a column. Oh, because we have a. I guess we're using the computer for this, right? Yeah. Here, so you also. Oh, this is. Once we slowly try to. Yeah, so you look at, you gotta get the document, like you stuff. You look at it, the first parameter should be the parent, right? And the second one is the replacement, where with the value one that was here, which is really more. Separate, so, I mean, we want to replace comma with nothing, right? So you want to go like this.
Let's turn a little bit more. I get this. Oh, because you're sending the entire data frame here, but you want to write down the specific column you want to filter out, right? It should be. See the next.
Oh. Yeah. Okay. So the reason is. Yeah, yesterday we kind of combined a bit of here, right? So you were saying here. Small. Okay. Yeah, so there was a bit about the piping in dplyr. So hopefully you guys now have some sense how to properly use the piping technique in dplyr. The next thing we're gonna do is we're gonna do some visualization using ggplot2 package. So ggplot, actually GG stands for grammar of graphics. So it has a certain grammar in it. So you gotta, I mean, you will learn like after some practices. But first you need a data set. And then secondly, you need some coordinate system, which I'm just gonna show you after. And then we're gonna select the geomes. Geomes, like, so how you want to visualize your data. So there are some predefined method in ggplot2. If you want to draw a box plot, violin plot, whatever the plot you want to plot, you want to call it after the coordinate system is done. And yeah, and then we're going to use the normalized effects data that we just created from the section above. Again, so we are sending, we're also selecting specific columns for this data here. So we are sending normalized data that we just created to the select function. We are selecting out date, county, vax density, fully vaccinated, and per 10K, and basically these columns that are listed. I mean, you can use all the data if you want, but like we're only using this 3 columns when generating the figures actually. So the date and then fully vaccinated and county. For those of you who had date as a capital letter here, you make sure you change it to capital D. And okay, so let's run this real quick. And then after that, we're actually also filtering out the population that has more than 100, actually more than million, right? What's that?
I think I was wrong, like normalized facts that have no solution.
Oh, okay. You might want to Okay, in that case, you wanna reload. You wanna go up where we calculated when we retrieve the normalized specs data. So you wanna go up to line 744 and regenerate the table again. Make sure you're filtering your NA with this method. It's NA with the exclamation mark up front.
Can also do with the exclamation point equal sign, right?
I don't think it worked that way. So if we use
You have to put it in quotation marks.
quotation marks. Oh yeah, yeah. But this will be a little different though. This is not true NA. It's gonna consider it as a word NA. You know what I mean? So it's better to use isNA function. Yeah, and again, once you generated the vaccination rate data frame, we can now pass it on to the ggplot. So ggplot. So first, so this is like a grammar, right? Like I said, so when you're visualizing using ggplot, you first call the ggplot function at the very first of the line, and then you pass on whatever the data frame you want to visualize, and then you got to define your coordinates x, y, and if you like the color as well, which has to be wrapped around with the aesthetic function here. So this is something you should memorize if you're going to use ggplot a lot. You can use this this workshop material as a reference, or there is also a cheat sheet that I uploaded on the GitHub. You can also use this as a reference too. And then what comes after is actually this one. So you want to define the geometry of what your graph actually looks like. So we want to we're going to use the smooth function here. There are different methods. Again, you can refer to the cheat sheet here. Maybe you can use geom point or geom area, geom density, geom box plot, geom dot plot. It depends on how you want to visualize your data, right? And then after that, everything else should be about like changing the labeling, the font size, and stuff like that. So what's most important is these two lines to generate the figure, and rest is just accessories, I guess. But you can go ahead, start running this code, and whatever the results that comes will be saved in the plot variable here. And if you execute plots after, you will see that plots been generated in the plots panel here. Okay, so as you can see, the total vaccinated people were highest in the Los Angeles area. You don't get it? You didn't get it? Yeah. Yeah, so you gotta just hide the plot and control enter. And it's gonna take a while and it's gonna upload it. Got it. Oh. So these are just labeled. You want to label it as a small b, then it's small. Plus.
Also, you have. So right now you're telling you need to hold it that it has negative. You don't have that. That's why you're doing. To try again.
I think this is a good time point to take a break. So we're gonna resume in 10 minutes, which is 10:15. And for those of you who are taking this course for credit, you can sign up your attendance here. There's a sheet up here. All right. All right, back to ggplot visualization. So we did create this sort of like a line plot, right? You can also change the geometry. So maybe geom point. And let's see what happens. Oh, sorry. There has to be a plus. So plus actually indicates continue run this line until there's no plus, right? Then if we do this, you will get similar plot, but now the plot, everything in the plot is dot. It's hard to see because the figure is kind of small, but if you like enlarge it, yeah, you see that now there, like everything is a point. Every data is plotted as a point, right? So you can basically play around with the different geometry method here. Again, you can refer to the cheat sheet here. Also, you gotta note that in the cheat sheet, they provide some of the default parameters you need to provide. For geom smooth, you need to provide the method, whether you wanna when you're like calculating this smoothing out of this graph, they're using some sort of like a linear regression model. There is different method available, but if you don't know how regression works, you can just set it as an auto for now. And then yeah, so like I said, the basic this is a basic syntax for the ggplot, basic grammar for ggplot. You always have to start with the ggplot function. You toss on your data frame, and then you designate the coordinate variable in your data frame, and then you get to choose whatever the geometry of the graph you want to show. So next in the line is for you to practice actually. So you can fill in the stuff in the axis. And see what happens. Sorry, just do it with you guys. Yeah, pretty much this, I guess, same plot. Oh, I guess we are plotting the normalized data here. So here we didn't say which one is X and then which one is Y. So order kind of matters, right? So if you don't designate X and Y, R is gonna assume that the first one that comes in as a X variable and the second one being the Y variable, and the rest being the third one being color. All right. So vex density, if you recall, we normalized that the vaccination rate with the population, right? So the plot we plotted before, yeah, so obviously we saw that Los Angeles has the highest number of vaccination, highest total number of vaccination people. But when you look at the normalized data, it's actually normalized by population. You actually see that so it's hard to determine here, but like actually the San Diego has the highest the vaccination density rate with the normalized data. Since this is as you can see, this is a lot of county data, so it's kind of hard to see. You can also separate each of these line by county. So vaccination rate, the second one should be the same as this one, the vax density, and the color being county. And then the function we want to use to separate the ggplot is a facet rep. So you designate which variable to separate. So if you basically run this, you see that yeah, so now that every line of the graph is kind of get separated by the different states. So if you want to like focus on individual data points here, you want to, in that case, you want to use the facet rep function.
So your plot has like all of the counties.
Yeah.
The reason that like we have a subset because of the filtering for 10K to greater than.
Yeah, I think mine's got kind of messed up along the way, but like the one you have should be the right.
Okay.
Yeah.
For the large counties. Okay.
Multiple graphs every time. What do you mean multiple graphs? Multiple types of graph, like generating a line graph and then box plots.
Yeah, so like we have if we have two different graphs so when we plot the other one, would it just overwrite the first one we plot? So like do we have to save each one of them
Yeah,
and plot the second one, or can
Yeah.
we plot like two graphs like side by side,
you can do
like
that.
arrange?
I think there is a different package for that. Or
I see.
let me try if this works. No. Yeah, there's a different package to add two different graphs into the same panel. I can look into it and share it to you maybe tomorrow.
Yeah, it's fine, no worries. So that is to say for now, for each graph that we plotted, you have to save it before plotting the other one.
Yeah.
Okay.
Yeah, also another thing you notice, we wrap all the date into this specific function, YMD. So the reason why we're wrapping everything with YMD is that this is part of the function of the lubricate package. So you kind of translate your character variable. So R automatically consider whatever comes after double quotation as a character variable, right? But we want R to consider this as actual date, right? So in that case, you want to wrap it around with the YMD function. There is also different way to use it. There is also MDY function, which basically means month, day, and year. So depends on how your dates are formatted in your data, you can basically choose different functions here. And then next thing we're gonna do is a violin plot. Again, same syntax. We're sending over the data frame that we're gonna draw, and then setting up the X and Y, and then color or fill variable, and then we're setting up the violin plot. And we are also using this color scheme called a scale fill brewer, and we're selecting a plate, pellets. We're using the blues only. There are different predefined color schemes. So if you search here, pellets, there are some predefined color combinations that you can use. Sorry. And then the labels are the same as before. So you can set up whatever the title you want to put in for your graph, and the y-axis labeled as well. So if we run this, and oh, sorry, I forgot to run this. So last month vaccinations, make sure you run this command before you run the violin plot. Yeah, so mine is a little big because my data apparently has too many states in it. Let me actually change that. Hmm?
I think I was saying violin. Oh, okay. Okay, no, there was something about.
Because I go here, A should be smaller.
This.
Yeah.
In.
Oh, it's morning sign. So it's just means that you want to scale to the floor. Scale better. Okay, so I guess for the second one, I want you guys to actually try it, fill in these blanks. Here you see that the plot we just generated before, all the X labels is kind of overlap to each other, which is kind of messy. So we wanna remove all the data in the X labels. So we are introducing the theme function here. So basically you wanna change x is text.x, which is basically change the text in the x-axis, and then we're putting it as a blank. So if you fill in all the blanks and run the code, you will likely have the blank x-axis at the end. Oh yeah, I also forgot to mention. So you can add multiple geometry on top of the other. So right now I just use the geom violin, right? So that's why you see the plain violin plot here. But if you add a geom point on top of it, it's you'll probably see. Yeah, points been drawn on top of the violin plot. And we'll just build this up. Yeah, as I said before, now that all the x-axis labels are gone, it's much clearer to see. I mean, we didn't need x-axis anyway, because all the county information is on the legend on the right here anyway, right? Yeah, sometimes when we are drawing graph, we wanna write down the standard deviation. For that, we can use our stat summary function in ggplot. So this is a basic parameter that must be added when you're running the stat summary. So the rest is pretty much the same. So we can add county and new doses administered. And let's see what happens. Yeah, if you notice that we also added, instead of a blank text, we also tried something else this time. In the x-axis, we trying to turn the angles of the label into 90 degrees. And then this is for the horizontal adjustment, we set to 1. And size of the text was set to 6. But this is too hard to see, you can always change it. So beforehand, we have a element blank to make it everything blank. But if you want to change the property of the text, you want to use the element text instead of element blank. So here we're only changing the x-axis. You can also change y-axis like this, or you can change the entire text in the graph with axis.text parameter.
It's saying without them, which one?
Oh, yeah.
And this mean SDL for standard deviation, the default has a, if you look at the manual for this, yeah, so the default for the constant value to calculate the standard deviation is 2 here, but we really want to set it to 1, because if you set it to 2, what's going to happen is it's gonna overflow your Violin graph a little. So you want to set it to 1 always. And this one is, and this one's pretty much the same thing. Yeah, so instead of using this function, this mean SDL, you can also create your own functions to calculate standard deviation. So standard deviation is basically mean as in the middle point, and the standard deviation is calculated in the plus and minus of that mean. And this is what this function does. If you guys recall, this is how the function is constructed. First, the function name, and then we call it a function, and then we put down whatever the code inside it. And then it's going to return the value, the y being the mean of the data we just sent in, and the y mean in the mean minus standard deviation, and the y max being mean plus standard deviation. And we can also use that function, our customized function, to a stat summary. So here, obviously the scale factor by default is 1. So we will see first run it, and yeah, you will see that the standard deviation is plotted as if we set this constant multiplication value to 1. Scale. Yeah, so something about geom, violin, and other geometry function that we run so far. So far we used the scale parameter. We used it for width, but there are different parameters you can use for geom violin. So if you look at the help documentation of geom violin, you look at the scale parameter here, you can either choose area or count of your data or width to scale down your violin plot. So if we actually change this width to maybe count, let's see what happens to the graph. Yeah, so if you use the count data, the violin plot gets too narrow. So you want to use the right scale factor if you want to, beautify your figures. And let's see what happens if we use area. Oh, still the same thing. I guess for this particular data, the width should be our best option. So we can actually see the violin shape, right? Yeah, same is true for geom smooth that we used. If you remember, we used a different method. Here we just choose the auto for the method up here, right? So if you put auto, it's gonna choose whatever the model that fits the data the best. If not, you can designate which model to choose. There are different model values here. LM is a linear model, GLM, generalized linear model, GAM, I'm not sure what the GAM loads is. I'm not sure what that stands for. You can also look it up on the web. There is obviously more information there. Yeah, so my, I guess, advice here is whatever the method you're using, you want to first look at the documentation here. Sometimes they suck. It's hard to understand even if you read it. So if that happens, you can always go to Google and search the community. Okay. Yeah, so before we move on to statistics stuff, I guess it's only a few lines. So you want me to just finish it and finish it early rather than take a break? Okay. Oh yeah, I forgot to mention. So something about lubricate. So if you use the lubricate, it's gonna. So if you use the greater sign, it's gonna be telling you whether this particular date is after this date, right? But if you don't use lubricate and if you don't convert your variable into date type, what happens is R is just gonna consider it as a character, and I mean R is kind of smart enough to tell whether this is number. So if this is number, that is gonna tell the number comparison basically, right? So here 0, 1 is same, so it's gonna pass on to the next one. 18 and 19. Obviously 19 is higher than 18, so it's gonna probably produce a false as a result. So you can see it. But if you actually wrap it with the lubricate function, here this is a month, day, and year. So that's why we are using MDY function here. So if we wrap it with the MDY, so obviously this is after this time period, because this is after 89 and 88 year, right? If you do this, you see that it's actually true. Because 89 is obviously after the year 88. So whenever you're dealing with date, it's nice practice. You always wrap your stuff with the lubricate function. Okay, so the next thing we're gonna do is we're gonna do some basic t-test. I know this is not a statistical workshop, but we're just gonna do some simple ones. For example, so from the last month's vaccination table, we're gonna take out all the county data from Los Angeles, as well as the San Diego. And just to recap, we're sending data frame to the pipe, which means we're sending this data frame to this particular function. Okay, so let's see how our data looks like. So this is San Diego vex data. Obviously, all the data from San Diego actually got filtered out. And for LA vex, same thing. Everything from Los Angeles was filtered out. And then, yeah, for the t-test is pretty straightforward. It's a default function in R, so you can use t.test for t-test, and then you can send in the values, the column, which is vex density. We want to see whether vex difference in LA vex density is significant from SD vex density. So if we run this, it's gonna tell you some statistical results. It's gonna tell you the p-value and the p-value, right? And obviously you see that this p-value is really small, smaller than 0.05. So we know that this vex density is significantly different between LA vex and SD vex. And this was true if you go back to our Violin plot. Yeah, I mean, just by looking at this graph, I mean, this is Los Angeles and this is San Diego. You can obviously tell there's a huge difference. And we did confirm that using the t-test as well. You can also try out different counties here. Maybe we can try San Diego to Orange County. Orange County is here and San Diego's here. I assume they San Diego. Oops. Yeah, so basically it's the same thing. We did a t-test for SDX, X2X, or OrangeX. And it basically tells us that even though they look similar, they are somewhat significantly different according to the p-value here. Yeah, so there is other basic statistical method pre-implemented in R. Other than t-test, you can do like one-way test or pairwise t-test. You can also do ANOVA, some Kruskal-Wallis for non-parametric t-test and chi-square test. You can also do linear regression model with LM function here. Yeah, I guess that's it for today's material. You guys can stay after if you guys have any additional questions. Please fill out the attendance before you leave. You're taking this course for credit. And yeah, thanks guys for coming. Oh. Not sure if there's well, you might also use it. So right now we're about RM with blue. Yeah. Now there's no light. Yeah. Yeah, so there is. I guess these two because the most things so you can
I'm writing my copy to myself.
Oh, that's one.
This is for grad students.
Yeah. And you got a roll. Something like that.
Have you ever painted it? No. I thought like, the slides like make no sense. There are like a lot of like pictures and stuff, and then I was like, I want to get this. Okay.
Actually, there was a typo in Max Violin. I think one of the A was capital. You gotta change it to lower letter. Yeah, one of them was like spelled in this way. Yeah, that was my fault. Sorry about that. Yeah. All right. Thanks, Kelsey, for the help.
Oh, I was muted. Yeah, thanks for the great class. Bye.
Bye. Yeah, yeah.
It's a little different. I'm still using the deep fire